help you understand the MergeSort sorting algorithm. I know this sorting algorithm can be a little bit difficult to understand at first because it has so many steps, but I'll break it down and make it simple for you. MergeSort is what's known as a divide and conquer algorithm. Divide because we split the array in half, forming two subarrays, and conquer because we apply MergeSort recursively to the subarrays, stopping when a subarray has a single element. We then combine and merge these sorted subarrays. It's also important to note that MergeSort is a sorting algorithm that requires an additional temporary array of the same size as the original one, giving it O of n extra memory required. So let's take a look at MergeSort on the following array. We have an array of 8 integers, so let's see how MergeSort would sort this. So MergeSort will sort by splitting the array into two smaller subarrays, each of 4 elements. So we'll have our left subarray and then our right subarray. So let's do this. Our left subarray will be 8, 7, 10, and 2. And then our right subarray will be the remaining elements. So we'll have 9, 13, 4, and 1. And this will form our right subarray. So then MergeSort will continue recursively. One thing to note about MergeSort is that it always sorts the left subarray first. So this means that we'll ignore our right subarray for now and move on to looking at our left subarray. So as it did with our original array, MergeSort will sort this left subarray into two smaller subarrays. So our left subarray will be 8 and 7. And our right subarray will be 10 and 2. So 10 and 2. As I've said before, MergeSort will work with the left subarray first, so we'll ignore this smaller right subarray for now and break 8 and 7 into two smaller subarrays. So this will break into 8, a subarray with a single element, and 7, a subarray also with a single element. Now that MergeSort has reached a point where each subarray contains a single element, a single 8 and a single 7, it's time to merge the two back together in order to each other. So let's do this. 7 is smaller than 8, which means that 7 will be the first element in this subarray and 8 will be the second. We've now completed our first call to merge. The first two elements of our array have been merged back together, sorted in relative order to each other. So let's continue. We break 10 and 2 into separate subarrays, and note that these also each contain one element. And so now it's time to call merge again. Since 2 is less than 10, 2 will be the left element of our new subarray. So we've merged these back together. Now that the left side of our left subarray has been sorted and the right side of our left subarray has been sorted, it's time to merge these two sorted subarrays back together. So 2 is the smallest element, so it'll be the first element of our new subarray, followed by 7, and then 8, and lastly 10. This is our third call to merge. And note that the left half of our original subarray has been sorted relative to each other. Now that we're done with the left side, we move back onto the right and do the same things we did on the left. So we break this up into 9 and 13, and 4 and 1. We then do what we did on the left side, and we break this down into a 9 and a 13. And now that we have once again reached single elements, it's time to call merge and merge these back together. Note that this is our fourth call to merge. Now that this has been merged back together, we move back onto our right subarray. We split this apart into single elements. And now that we've once again reached single elements, we merge these back together. 1 is less than 4. So 1 is our first element of this subarray, followed by 4. And this is our fifth call to merge. Now that these two subarrays have been sorted, we can merge them back together and sort them relative to each other. And now that the left and right subarrays have both been sorted relative to each other, we can perform one final merge to get our final sorted array. So 1 is the smallest element of these two arrays, followed by 2, and then 4, and then 7, and then 8, and then 9, followed by 10, and lastly 13. So this is our last call to merge, and now we have a sorted array of integers, with our smallest element first and our largest element last. I know MergeSort can seem a little daunting at first, especially when you look at the number of operations and how it looks to trace it, but as you practice, it gets easier and easier over time. Let me know if I can explain anything better or if you need help understanding a specific aspect of MergeSort. Practice is the best thing, and you'll have MergeSort down in no time. Have a nice day.